6.4. And now 6.1 through 6.3. Functions of several variables. Functions of several variables. Okay, we can have functions that have more than one variable. Here's an example. We can have f of x comma y. We can have f of x comma y comma z. What do you think we're going to do in 6.1 to 6.3? We're going to study some of these functions, and we're going to find their maximum. And that's it. But first of all, first type of application, we are given a function. Let's say problem 8 on page 531. So here is f of x comma y comma z, and the function is 2 to the x plus 5zy minus x. They're asking us to find f of -1 comma 2 comma 3 and f of +2, -1 comma 3. -1, 2, 3, and 1, 0, -3. Sorry, you're not keeping an eye on me. 1, I copied from a different problem. It doesn't matter. It really doesn't matter. I'm just illustrating how to evaluate these functions, which has nothing to do with anything other than what we've been doing for one variable. So the second point, I'm sorry, was 1, 0, -3. 1, 0, -3. So I'm sure you know what we're trying to do. So this will be 2 to -1 plus 5 times z times y will be 5 times 30 z.
Then the first one is different as well.
Oh no.
It says 0, 1, -3.
Okay. 0, 1, -3. Keep an eye on what I copy, because when I look in left and right, that's what I do. Sorry about that. So this is not needed. And so 2 to 0, 1 plus 5 times z times y will be 5 multiplied by -3 and minus 0. So the answer is 1 minus 15, -14. So this is a function of 3 variables. And we evaluated it at 0 for x, 1 for y, -3 for z. Nothing so far, correct? Let's determine the other one as well. 2 raised to 1, and this is 0, and then -1. So the answer is 1. So obviously no questions, right, in evaluating these functions. Now let's determine domain. We have to be very careful with domain of these functions of several variables. Domain. Here it is. Please choose, because if I choose, who knows what happens. So from 9 through 14, any problem? On page 531.
Number 11.
And number 11 it is. Okay. The square root of y, f of x comma y, is the square root of y minus 3x. Perfect. So how do I determine the domain of this function of 2 variables, x and y? It's the square root of y minus 3x. What do I have to write? The only thing that I can write. Y minus 3x must be, it's under the square root or equal to. That's all we can do. We cannot solve this. So the domain is all ordered pairs x comma y with the property the property or knowing or given that y must be greater than or equal to 3x. That's the domain. See if we need another. And now let's look at some business applications.
So I'm sorry, the phrasing for that again, you said it's,
The square root, yes. So the square root,
no, I'm talking about the phrasing for the domain.
oh yes.
How you-
So the domain, in this case, is not made for x. It's
right,
not made
X
for
and
y. It's x and y because the function is a function of two variables. So we say the domain consists of any ordered pair on the planet, given that, or having the property that y must be greater than or equal to 3x. So let's look at an example. It's a very good question. So if x is 3, give me a possibility for y. Exactly. Another possibility is 3 comma 10, and so on and so forth. As long as the condition is fulfilled. Because if the condition is not fulfilled, then I will have the square root of a negative number, and we can't take the square root from a negative. So the domain this time is not for x. The domain is for x comma y. So we're talking about ordered pairs. Given that this condition is fulfilled. Maybe we should look at another. So choose another.
I don't have a book in front of me, but we can do 14.
14 it is. Well done. Perfect, 14 it is. In 14 we have a function called k of x comma y, and that is 1 over x plus y over x minus 1. Okay. Any restrictions that you would like to mention?
Is it X cannot be equal to 1?
And what else?
0.
Yes, and x cannot be 0. Any restrictions for y? No, very good. So then the domain will be all ordered pairs x comma y, given that x is not 0 or 1. With any y on the planet, any y will work for this particular problem.
So this is just basically seeing what restrictions you have.
For all of them.
For,
But in this case, for both.
Yeah.
For this particular problem, we did not have any restriction for y.
just given the information you have, find the restrictions based on what will have restrictions.
Yes, exactly. And the rest is free.
That makes sense.
It's not that.
Now, are there ever any I'm not reasoning through it at the moment, just asking the question. Will there ever be any math problems where you have to differentiate, or like anti-differentiation maybe, or
No.
differentiate?
Differentiation, yes. However, the differentiation cannot be done as we did it before.
Is that beyond what we're learning here?
No, we're going to learn this.
Oh.
Right, I'm gonna show you right now.
Okay.
Right, yeah.
Right now, since you mentioned it, yes, let's do it right now, and then we'll come back.
Okay.
So that is my next step. That is exactly what I was going to do next. So we'll come back to word problems in a minute. Okay, on page 539, we're going to look at a function. I'm going to choose a nice one. There is nothing really very nice in this book. Okay. Problem 6 on page 539. That's the easiest I could find. F of xy, unless I copy something else. 5x plus 7y we are asked How many variables are we found, or does this function have? Two. We cannot differentiate with respect to x and y at the same time. Since the function has two variables, we will have to use this notation. Careful. This is called a partial derivative. We are differentiating the function with respect to x. And we are assuming that y is constant. Also, we can differentiate the function with respect to y when we assume that x is a constant. So let's start with df over dx. But it's not a straight d, but it's that curly d. So when I differentiate this with respect to x, I get 5. But there is no x here, so when I differentiate this as a constant, it's 0. What about df over dy? This is a constant, so the derivative is 0. So then the answer will be 7. I know this was too easy. Also, this notation for df over dx is also called fx, the partial derivative of the function f with respect to x. What do you think we're going to call this? Fy. But it's not f parentheses y, it's just f sub y, correct. Okay, so let's look at a more serious situation. Yes, go ahead.
That problem says find the f sub x of that, and then it gives the 2 points.
Yes, but I don't have any x and y to plug it in. So it's still 5 and 7, still 5 and 7.
Oh, okay.
Because there is no x.
The original, you plug this into the derivative.
Yes, yes. Because it's fx, so we're asked to find fx of -2, 4. So the answer will be 5. We're also asked to find fy of 4, -3. So that's still 7 because there is nothing I can plug it in. There was nothing left. No x, no y left. So let's look at another problem. Okay, so what about a more serious situation, like still 2 variables, or we can move on to 3 variables if you'd like, but it's the same idea. Let's say 40 on 540. So we have a function of 2 variables, x natural log y. And the question is, they're asking us to find this time, I'm going to add here because we have to do this too, fx, fy, fxx. What do you think fxx would mean? It's the second derivative with respect to f. So this notation would be d2y over dx2, or fxx. What do you think fyy will mean? So because I don't want to confuse you, I have to change this into f. In this case, I cannot replace f by y. For a single variable, I can, but for this one, I can't. So this will be d2f over dy2. Final question before we calculate them. What do you think fxy will mean? So it will be, first of all, with respect to x, so df, right, with respect to x will be the first one. But this time will be d2f dx dy. We don't have to use these notations. They are somewhat confusing, but that's clear. After I differentiate with respect to x, then I want to differentiate with respect to y. what would be the reverse? I differentiate with respect to y, and then I would differentiate with respect to x. So let's look. So f of xy equals x natural log y. Let's find fx first. We are differentiating the function with respect to x only. What is the answer? So this is a constant times x. When I differentiate the constant times x, I get the constant, natural log y. So this is clear. What would be f of x, fxx? So I differentiate this with respect to x, but this is a constant. There is no x in it.
So it's just 0.
Exactly. Now let's determine fy.
Just do the same thing you did before.
Yes, but now x is a constant. So x stays outside times I differentiate natural log y. What do I get when I differentiate natural log y? And y is the variable.
1 over 1.
Exactly. So this is x over y. Well done. But now I want to find fyy.
But how come in the first one you got rid of x?
I didn't. So in the first one, x is the variable. When I differentiate x, I get 1, but the constant stays.
Oh, okay. So
Because that's the constant. Imagine this is like 3x. When you differentiate 3x, you get 3. When I differentiate log yx, I get log y.
But technically it's 1 times that, right?
Exactly.
Okay, I just.
Yes. So then when I differentiate this, which is a constant, when it comes to x, there is no x in it. When I differentiate, I get 0. When I differentiate this with respect to y, this is the constant, stays outside. I differentiate natural log, and I get this or this. But now when I differentiate this with respect to y, I would rather rewrite it first as x times y to negative 1. And I'm differentiating with respect to y. I bring down negative 1, so it's negative x times y to negative 2. So this is negative x over y squared. So let's see what we accomplished so far. fxx, fyy, but now we have to find fxy and fyx. And then I'll stop. I think, yes, 3 minutes. Okay, so fxy. So this is fx, but now I want to differentiate it with respect to y. What will I get?
1 over 1.
That's it. Excellent. So now fyx. So this is my fy. And I want to differentiate this with respect to x. What do I get?
1.
Over?
Y.
Exactly. Notice something very interesting? Yes. That's what's going to happen. fxy and fyx will be the same.
So we'll always have to find the 2.
Yes.